All right, let's talk about virtual LANs or VLANs. Perhaps you've heard that word before because it is one of the most common concepts in networking. What does it mean and what are they used for? In short, VLANs provide logical segmentation within a network. The slide here says that it does so by creating multiple broadcast domains on the same network switch. Yes, this is true, but I also don't want you to misunderstand the information. So to clarify, it does not mean that particular VLANs can only exist on a certain switch in the network. They can span over multiple switches across the network. I can actually explain and visualize the concept in our topology diagram if I jump onto EVE-NG. So we have a simple lab running in EVE-NG consisting of 3 switches connected in this triangle. So right now, this is one big flat layer 2 network. There's only default configuration, no logical segmentation or separation exists at the moment. All of the devices are one big happy family. Now with the introduction of VLANs, we can create logical boundaries and form that segmentation within this network. To demonstrate the concept, let's actually focus on switch 2, where we have PC1 connected. So right now with the default configuration, the entire switch 2 is actually in VLAN 1. Now with the use of VLANs, we can leave PC1 in VLAN 1 as it currently is, and then we could create other VLANs to provide that logical separation. So we could do something like have PC1 and perhaps even other ports or devices connected to the same VLAN, VLAN 1, and then add another VLAN over here, let's say VLAN 2 then, with another computer, another PC over here. Very beautiful. So this is the main idea of VLANs. By default, devices in these separate VLANs will not be able to talk to each other at layer 2. The packets would need to be routed at layer 3, but more on that later. Okay, let's scrap this drawing for now and then move back to the slideshow. Here. So as I already mentioned, devices in one VLAN cannot communicate with devices in a different VLAN at layer 2. That is really the whole point of the logical segmentation. Now VLANs are defined in the IEEE 802.1q standard. So whenever you hear 802.1q, think of VLANs. Now the use of VLANs adds 32 bits to the packet header. And this is represented at the bottom of the slide. So you have the typical frame format with the VLAN tag added in it. It's squeezed in there with the other fields. So if you look at the 802.1q tag over here, we'll look at that in more detail in the next slide.